Welcome everybody, and thank you to the Engineers Ireland Civil Division for giving us the opportunity to showcase what we believe is a flagship scheme. Anyway, we have a couple of them, but we're particularly proud of this one, and so it's great to get the opportunity to share it with you all. So thanks for joining. I'm Joe is my name. I'm working with Dublin City Council. I'm part of the active travel team. So I know the guys have I've seen the slides. They're very interesting, and but I'll just give a brief introduction to the active travel office who are kind of delivering the scheme with the NTA, and it just might be useful for the group that are joining for future schemes that are coming up. So so in as I say, I'm part of the active travel office. Our strategic goals are similar to the NTA's when it comes to active travel, and we have a vision, I suppose, or the office has a collective vision, shall I say, for essentially for a safer, inclusive, sustainable walk, wheel, cycle network. So the actual the office, the active travel office, it's relatively new in Dublin City Council. Just to mention briefly, we're established early 2022, I should say. We had a launch of the network, the envisaged network. I would hope to roll out over the next 6 to 8 years. Later on that year in October 22, and we're residing in just off Smithfield Plaza there in Cavendish House. So we're a relatively new entity, and we're building our team, and you know it's a vibrant, active team, and you know there's huge enthusiasm. So essentially, all I'm working at the construction end, so it's the back end of it. We actually have design teams and lots of delivery partners as all tied up in that, trying to pulling the same direction with the same goals. Essentially just to improve the access, get a sustainable mobility up and going. And I suppose ultimately what it comes down to, popular or unpopular as it might be, the reprioritization of the road space. So I suppose that hierarchy that typically would have been everyone is aware of, you know, going back over the years in Dublin city centre, it's just trying to rebalance that into the different modes. So I suppose just again I just want to suppose share the strategic vision that our office and the NTA have looking forward for Dublin City. There is joined up thinking. Essentially ultimately what we're hoping to achieve is that 95% of the population will be within 400 meters of the network. And that I could probably do half a dozen slides on that network, and my colleagues would do a better job than I. But that is the network that we're targeting for 2028. Some of the dark blue ones there, as I say, I appreciate it's not extremely easy to identify, but the dark blue ones there, say are the ones that we hope to deliver this year. So you can just about see. If the cursor will work for me. There's Clontarf City Centre, which we're going to talk about now. Colleagues working on East Coast Trail that opened there in the last couple of months, and then there's the Royal Canal Phase 3. There's a section of that opened up already, and so it is the hard work over the years, and I suppose I'm at, as I say, at the back end. There's a lot of work over many years by others, and it is starting to come to the fore. There's plenty in the pipeline. 2025, you'll see Finglas Village up there, up in the northwest. We have Clonski to the city centre down in the excuse me, I said the southeast. Up in the northwest is Finglas Village, Clonski down in the southeast, and then there's more the Royal Canal to come next year as well. North Circular Road. So it is. There's next year we hope will be a busy year for us as well, and continue to start getting boots on the ground and getting these schemes built. And then we're obviously BusConnects is all tied up in that as well, and it's just essentially a cohesive plan, and there is a strategic plan there to keep going right through. So I just thought I'd share very briefly. Some of it, these are the schemes that are on the ground at the moment. You can see we were lucky. We have great delivery partners engaged with us, and the work is progressing. You can see Clontarf City up the top. Then there's the Dodder Greenway that opened a couple of months back. East Coast Trail, the third one that opened again. It's just opened relatively recently. You might have passed it on East Wall Road. We're down on the quays. You can see us on the quays. Just again reprioritizing lanes and access. And then the Royal Canal Phase 3. That's another big one that's on the ground at the moment. There's a good section that already opened, and they're on course to open the remainder of the scheme. I think it's summer next year. So you know they all they're beginning to get rolled out, and once they get rolled out, there's interconnectivity involved with all of them, and hopefully the network then will start to shape up. Just then, we're all here. The purpose of this evening is to discuss the Clontarf City Centre scheme. As Joe mentioned, there's quite a history, and there's more people than I'll be able to mention involved in the scheme have helped it to the point where it is today. So I think there was option assessments going back to 2012, and then it worked its way through. We got part 8, which was the back end of 2017. There was conditions associated with that, and there was more work for Owen's team, the RD team, and then ultimately we through the tender process and we landed on site March 22. March 22 is when it started. So it's not, it is called, you know, people said to me, it's you know, you're 2 years, 2.5 years for a cycle track. It's to be fair, it's as a general introduction, all the slides the guys are going to show you, it's far more than just a cycle track. It ties into the Balgriffin BusConnects scheme. We've 14 brand new bus stops that are BusConnects ready. We were the biggest water rehab scheme, I think, in Dublin. 6.5 kilometres of water main, brand new public light, 250 public lights, massive public realm upgrades, 6 or 8 big plazas, brand new junction upgrades, you know, kilometres and kilometres of ducting, and just and general, you know, what often goes unmentioned, the road. I think over half the area was completely brand new road construction, which is phenomenal undertaking in the city centre. So it's, I suppose, in a nutshell, it's just far more than the installation of a two-way cycle track. Just very briefly, obviously these are all the main delivery partners per se. So project sponsor is the NTA, and obviously they're funding it, and we're working closely and cohesively with them we all have the same pulling in the same direction. And then it's with us, Dublin City Council, to actually deliver it. So we work very closely with our elected reps, and they were obviously involved in the part 8, and we have an ongoing engagement throughout with the guys there. And then specifically in Dublin City, then there's the active travel department, which I mentioned, part of the overall E&T department, and I suppose I was trying to think how do I summarize what we do on a day-to-day basis. I suppose we kind of sit in the middle. We work closely with ROD, the contractor, we have all the stakeholders. We spend a lot of time engaging with those as best as we can, and they've been very engaged, and it's been you know, it's been worthwhile all the way through. We've comms, like, for long sections of the 2.5 years. It's a 7-day, 24-hour scheme that runs along non-stop. Whether you're at the top end of the scheme, you're doing duck crossings, to the back end of the scheme, you're lane wiring course. But it is essentially, there's chunks of that, 12 months of that is a 7-day, 24 hours. So it's you know, it's out hours, it's at night time, it's holding traffic up at the weekend. So there's a huge comms element as well that we try grease the wheels on as well to keep moving. You know, there's Victor Coe, he's the PRE on the job, and then I'm lucky enough to have a team. There's Mohammed Abed, there's Tony Breen and John Heffernan as well there, who was with the team for a while. So it is a massive scheme, and a huge amount of moving parts, and yeah, no, it's been fulfilling anyway. We're close to we're at the back end of it, and it's been an experience. Obviously, Roughan O'Donovan, who you'll hear from now in a moment. Again, we rely hugely on them for their design and their input, and their engagement throughout has been great. And they're a main contractor. I know Joe alluded to, you know, Clonmel. We've worked very well with them, and it's there to be seen. It's, you know, we're very close to completion, and it's there for everybody to see how the construction has gone. So yeah, I'd love to have Clonmel in on another day and let them share the experience from their perspective also. I did just want to mention we have a consultative forum running. I think we're on meeting number 23 or 24. So it's a quarterly meeting we have, and we have an independent chair, and essentially we have the elected reps from the areas. They come in. They're usually very well attended with the local businesses and residents that they all attend. And then there's some other interest groups. So as the scheme that goes on for 2.5 years, there's just changes as you work your way through. There's bits that you want to communicate to the elected reps, to the interest groups, and it's been a fantastic mechanism to actually flag to say in 2 months' time we're going to do this, or we have a design tweak that we want to do, and so it's certainly if I was lucky enough to be on such a scheme in the future, it's been a huge benefit to us to just share our proposals and share our vision and try to get as many people on board. So my last slide, you'll be glad to hear. I just couldn't stand here today and just acknowledge without acknowledging, there's Chris Manzier's team and there's Fiona Craven. There's it's gone on so many years. There's a huge amount of work gone into it. But then there's also all the other departments in DCC, and again, for anybody delivering in one of these schemes in the future, I'm not going to mention any of them there, but because the scheme is so extensive, it crosses so many departments. It literally the entirety of Dublin City have pulled on this one and have delivered. There's just huge engagement. There's huge knowledge there in the background that I'm learning every day. That there's so many people invested in their entity and have massive knowledge, and they've given us huge time, commitment, and expertise. So again, I would suggest if anyone was involved in these one in the future, I'd suggest I'd request do take the time to engage with all the departments in Dublin City, because there's plenty that they can help with and assist, and they're keen to share their knowledge where they can. So just thanks to all my colleagues there. I will mention the business groups, residents, members of the public. Like we have been camped outside on the roads for the last 2 years, and there has been huge patience and cooperation and everything with those. We do try and engage as much as we can, but one of these schemes can't be delivered without the cooperation of the general public. We had a significant diversion in place for 2 years, and again, it impacted on a commuter. So just again, without mentioning anybody or any particular group, just grateful for everyone for their patience and cooperation. So that's all I have. So thanks again to Civil Division for having us, and yeah, I look forward to coming back to maybe next year with another talk. Thank you very much.
So it's myself, Thomas, and Colin will be presenting. Thomas will go through various design details. Colin will pick up on a few more of those that he was involved in, and I'll give just a general overview of various stages of the project. So it's a 2.7 kilometre route, and you see some graphics I robbed from Joe here. There's an awful lot in it. Plenty of trees. We did 500 metres of the greenway along the Tolka as well. That had been closed off, antisocial behaviour under the railway bridge for years. That's open again now, and it connects to the East Wall Road scheme Joe mentioned, and it also connects on to our Dublin Port Greenway, which opened in the last few days as well. So it's great to see this network coming together. The guys will go through some of the complexities involved in the various elements in the graphic on the left there. So background to our involvement. So we were actually initially appointed to prepare the feasibility study in 2012. Then another consultant was appointed to progress the preliminary design, and that led to a Part 8 approval in 2017. So it was actually already AECOM, it was an alliance commission. We did most of the design, but our colleagues in AECOM, I see a number of them here today, also very welcome. They did all the business case work for us on it. Now, the Part 8 approval was unusual in that Well, for anyone, the benefit of anyone listening, Part 8 approval is an approval granted by the local authority to itself. So it's voted by the elected members. The elected members, though, put in a few very onerous planning conditions that took us a while to figure out. And there was a lot of controversy about trees at Fairview Park. So the first one was to retain trees at Fairview Park, but then they introduced these requirements for protected intersections, which nobody really knew what that meant at the time, and for segregated cycling facilities at bus stops, which has given us no end of headaches for the last 7 years, and I'm sure will continue for the next 7. So basically, before we could get stuck into the detailed design, we had to redo the preliminary design. So the trees at Fairview Park is, you know, a very big, fine inner city park. There were trees planted along the edge of it, and the original scheme was taking those trees out to facilitate the road widening. So we had to kind of have another look at how to manage traffic and that to avoid that, which we managed to do. And so, yeah, we ended up quite a different scheme at the end of it all, but it did get us over that difficult hurdle. The segregated bus stops, so effectively, you know, we had to separate the waiting areas for pedestrians from the footpath, because the only way to segregate a cycle track at a bus stop is to bring it behind the bus stop. You can't bring it outside the bus. So there was no end of wailing and gnashing of teeth trying to get these right, and crossings and what the implications are for various, you know, any type of crossing is challenging for various different types of road users, and no more than all the international experience, this was a real challenge on this job. And the design of those crossings changed multiple times. When we started, it was before the BusConnects design program. So like the design of this scheme was basically done between 2017 and 2019. So we had no design standards to work off. So we had to devise our own design standards. And that's what you see out there today. I'm very pleased with it. So what we put in, we decided to allow a double bus stop everywhere we could fit it in, and much better shelters than were out there, consistent treatment along the route. And then we had gentle curvature on the cycle track as you came in behind the bus stop and out again. That's what one of the finished articles looks like at the bottom of the Malahide Road. That's Marino Crescent, where Bram Stoker is from, in the background there. So, I mean, this is the first picture of the scheme you see, but you see the quality of the finish everywhere on this job. This has been a very expensive job, but it's because it was done to a very high standard throughout. So finding all the space for these island bus stops, they obviously take up a lot more room than just having a pole on a footpath, because you have to find all the space for the bus islands separate to the footpath. So that's another 2.5 meters on each side of the road. And you're trying to squeeze this into a very dense urban area. So we had to basically find places along the route where these would physically fit. We then had to look at what the spacing would work out at, and what that meant for services. And again, you know, Joe has had no end of headaches as a result of what we did here in terms of removing bus stops and all that. But it all leads to part of better service, having bus stops at fairly regular intervals, high quality, improves the reliability overall. So we moved quite a lot of them around, but we managed to do it anyway. We also wanted to keep the main line smooth so that the buses would fit in narrow enough lanes, and we ended up with about 400 meter spacing. The next tricky one was these protected intersections, which I think were something conceptual, but didn't actually exist when we came to looking at this first. Obviously, our junctions in Ireland and Britain are different to quite a lot of the rest of the world, in that most of the world allows you to make the left turn, or the equivalent of our left turn, which is a right turn in a lot of instances, through a pedestrian crossing, whereas we don't. So you have to marshal everything separately. So these layouts became very complex. So this was actually the first one of these junctions designed in the country. It didn't end up being the first one built. So one thing we were very anxious about is, as cyclists, I mean, I must emphasize that our team are cyclists, and we look at the design from the cyclist perspective. is that you don't want a situation where the light is green for cars and red for bikes at the same time, because cyclists will just ignore it. I mean, it's hard enough to get cyclists to pay attention to traffic lights at the best of times, but if you antagonize them, they'll absolutely ignore it. So we had to find a way of running the things together. And so you're separating the cyclists from the traffic on the one hand, but on the other hand, you're trying to get them both to interact with each other and run at the same time. So this was very challenging in terms of how you get everything intervisible to each other as you come through. And look, we were pretty nervous when this opened the other week. When it, the main line had been closed to traffic, when it reopened again and all the traffic was coming down and making these left turns, there was a few nervous moments, but it seems to be working, thankfully. So we've got, flashing ambers for the left turns now to distinguish them from the priority straight ahead traffic has. So that was the original design we got on the left-hand side, which was the planning design. And on the right-hand side then is what we ended up with. Continuous footpaths. This is something I'm really pleased with this on the scheme. I'm really proud of what we've done here. We've changed the priority at minor side roads. And we, again, we were out on a limb here, but it was one of the first real positive reactions we got from the public when the first one of these opened. I mean, there's no doubt looking at that the footpath has priority, the cycle track has priority. More recently, other guidance has come out suggesting there might be tactile paving back a little bit from it. That obviously wasn't out when we designed this, wasn't out when we built it. But, I'm pretty happy with how it's working as it is. But, we have to build things sometimes and see do they work or not. Other issues then we had to come up with, we had the cycle tracks under the Loop Line Bridge. We had to tie into Newcomen Bridge, which was actually built as an enabling work for this job. We had to move the retaining wall you see on the bottom right down there, the historic wall coming up to Newcomen Bridge. We had to move that out into the road and rebuild it. The greenway through the park, the Talca River Greenway under the bridge. We had to adjust some car parks, lay by at school. And actually what you see there at the top right is how you switch from having one-way cycle tracks on both sides as you come to the Clontarf Promenade to bring it all together. So that was a bit of a challenge as well. But look, I think it's worked out fairly well. The job couldn't have been built. I mean, even though it's gone on 2.5 years, it could not have been built if we had to keep all the traffic on the road during construction. So DCC went to great efforts to persuade the project team, to persuade their colleagues and the elected members that, look, we just can't take everything through this space and build it at the same time. It'll take 10 years. So after a lot of persuasion, the road was closed to inbound general traffic. So we had then a bus lane inbound, a bus lane outbound, and a outbound general traffic lane. We had actually proposed initially only having one lane outbound and having a cycle lane each way as well, but the NTA wasn't happy with that. And in hindsight, it's just as well, because if we'd had the 2 cycle tracks and the 2 traffic lanes, we would have had much less scope to do some of the awkward connections. Whereas when we had the outbound bus lane and the outbound general traffic lane, we could close the outbound bus lane for periods, and that gave us scope to do stuff in the middle of the road that would have been impracticable otherwise. So the diversion went on for over 2 years. And, as Joe has said, I think the project team is extremely grateful to the forbearance of the public and the businesses during that period. But hopefully the end product is worth it. We then had to deal with land acquisition, approvals, working around structures, duct approvals, the business case. Of course, AECOM had to put long hours into getting a business case to justify the kind of expenditure we're talking about here. But I mean, the business case was positive for the scheme, was quite positive. And I suspect, if anything, the benefits will continue to grow. Site compounds. This is something any of you working on BusConnects are no doubt aware of, but it is extremely difficult to get site compounds in Dublin. And the closer you get into the city centre, the harder it gets. So finding areas where we could store all the materials needed for this job was a very big challenge at the start of construction. And it took a lot of negotiation by Joe, Victor and that team to make it happen. The consultative forum, Joe mentioned, the consultative forum has been running since more or less the start of our involvement in the project, and it is by far the best thing we've ever done on a project like this. Getting everyone involved in it. It got to the point, where the people on the consultative forum were going out selling the scheme to their neighbours, which was brilliant because they became part of the project team. So I'm going to hand over to Thomas now, who will run us through some of the utility design stuff.
Hi, thanks. So, you're probably looking at the photo to start and say that's not the same guy. 7 years later, lost a head of hair, getting 2 kids. I don't know which to link to lost the hair, the project or the kids. So, so I'm going to talk through utility design, the SuDS implementation on the project, payment design, contract documents, production, and then also a little bit on the consultation with the various people. So huge part of urban city centre design and construction is the utility design. Sorry, so I'll go back a few. So we had 15 different utility providers through the site. By far, ESB, Air, and the DCC departments were we've engaged with the most, due just to the quantity of ducts, everything else that was in the system. So on the right there, you have just some details of the quantities. I'm going to go a bit more into the traffic signals and the water mains. So, for the public lighting, it was a full new public lighting scheme throughout the whole route with 283 new lighting columns, which is a huge amount, 8.5 kilometers of cabling and 7 kilometers of ducting to facilitate that. And all of these was a new ESB supply as well. So just on the traffic signals, because there was nine junction upgrades, 3 existing peg crossing upgrades, 2 new peg crossings. There was a huge amount of infrastructure there that we needed to design and change. 91 RS115 sockets, 48 RS168 sockets, ultimately resulting in 18.5 kilometers of ducting, which included 1 ways, 2 ways, 4 ways, 6 ways. And it's a huge undertaking to provide a new traffic infrastructure around every junction. I don't know if anybody's aware of the DCC standards, where you have a 6-way loop around the junction, while keeping the junction live. Getting the new system in while maintaining the existing was a huge challenge. Picture there in the bottom left shows just some of the sort of ducting that you see going into chambers. So that's including a new 4-way fibre link that we provided for the whole scheme. And that fibre link allows DCC traffic management to actively manage each of the junctions here. It provides them with a new link up to Dublin Port Tunnel. The system that they're working on at the time, or up to the completion of the scheme, was through small patches of their own ducting system rental from other utility providers. It just really wasn't ideal. They were over capacity. They needed more capacity, and it's a great win for them, because then they can actively manage all of these junctions at times of congestion. Just for the detailed design, as you said, there's 91 RS, 91 115s, 48 168s. The picture there at the top right is one of the sockets, and you can see the scale of the foundation required. So this is to go into a junction, and you've seen the 5-lamp junction. It's a very constrained site. We've got about 10 or 12 of them in that area. So you have to look at the versions, you have to look at what's the existing, what's proposed, getting power to it, getting comms to it. The picture there at the bottom right is a traffic controller, and that's a traffic controller cabling. You can see the cage to the left is the new traffic controller. So while you're trying to get while you're keeping the junction working and then trying to implement the new traffic controller, the new system, you can see that it's a huge undertaking, a spaghetti junction. And fair play to DCC Traffic. They were always there when you needed it. They worked well with the contractor. They always gave us their time and expertise whenever we needed it on site. So that was a huge win for us. So just on the utility design process, so we look at it in a sort of 3-step process, where it's identify everything you have, verify, and then into design. So some of the design tools that you can use to do the design is utility records, which we all know can be not worth the paper they're written on, but it gives you a good general idea of what infrastructure is along the route. Next, your topo survey, your utility survey, your ground investigation, and then site visits. And I put in Google Earth because it is a great tool. You can pop down to the point of the street, zoom in, and you can tell if a chamber is aircom or if it's ESB or something like that, just about by the markings. So for the verification, so as I said, we had a GPR survey. I'm going to focus on the GPR survey and the slit trenching. So on the left there is a GPR survey for the 5 lamps junction. You can see that that's all of the existing network. You can see there's very little road space left when you're looking at it in that network, and each of these is just a 3D polyline. It doesn't fully take account for the diameters and other things for the utilities. And then on the right there is the slit trench. Our original GI contract had a huge amount of slit trenching, which we thought was required. It was pared back for a number of reasons. It was traffic management, cost, time, a lot of things. But it is immensely important that you do the slit trenches to verify your 3D survey, your 3D utility survey. I still think the 3D utility survey is the best tool we have. It gives you a better idea of the full spatial of a lot of the utilities. But you do need to do the slit trenching, especially in these urban environments. It might have saved us some headaches if we had a little bit more slit trenching during construction. And then on to the design process. So we have a 2-step design process. It's a 2D design and then a 3D spatial design. So you see there on the right, that's a 3D solid model of our existing utility survey. So you can see the complexity and the chambers, the different ducting, the big brown pipes going down the middle. They are existing combined sewer systems, where at some sections of the project we had 4 of them across the road, which made it hugely difficult to get any other sort of infrastructure in. Majority of them are quite deep, but it still can be quite challenging. So our 2D design, we initially do our planner clashes with the new infrastructure. So we bring in everything that's a sort of a movable object that we don't have any scope over. We bring in our lighting, our gullies, our tree pits, our bush shelters, traffic signal pole, foundation, drainage. They're sort of all immovable objects that are part of the scheme, but we can't really move that far. So that then identifies what our diversions are. And a lot of the water main design came out of this. Once we put all of our infrastructure in, we had so many water main diversions that it was just a patchwork of the existing and proposed. And that's sort of twigged in our mind that this is not going to work. And we started talking to Irish Water about a full diversion across the whole scheme, which was a benefit because a lot of the old water mains were located in the path. So when we could move them out of there, it freed up a lot of space for other infrastructure. And then we went on to the 3D spatial. So we have to strip all of the diversions out of the model, bring in all of our proposed, and then we went through a Navisworks flash detections operation. So like we know the limitations on GPR and utility surveys. It has its tolerances of where it might think the service might be. So in the Navisworks, we did hard clashes. That's a straight clash. But then we started looking at different bits of infrastructure where there was a distance either side of it, maybe 100 mil, 200 mil, and then looked at those in a bit more detail to see if we actually needed to do a diversion. Just onto the water main. So as Joe said, it was the largest single water main renewal project in the city to date. So we had a huge amount of water main, existing water main across the route. You can see there on the right, everything from 1900s up to 1950s of every conceivable size that you would think. We have full of hydrants, loose valves, butterfly valves, meters, bulk meters, and associated telemetry. DCC and the NCA did a huge amount of the heavy lifting with Irish Water to get this across the line, which was great. So the proposed design in the end had nearly 6,400 meters of water mains, 236 sluice valves, 56 hydrants. We had 108 bespoke connections. So when we looked at the 3D spatial design, we initially started with, as every engineer does, to the Irish Water connection detail. But then we started looking at that. There was so much congestion that wouldn't have worked. Your sluice valve might be 5 meters away purely because you wouldn't get it in spatially. So we came up with 108 different bespoke connections. When we sent them to Irish Water, we only had a handful of comments back, which was a huge win for the design team. So on the right there, you can see the different lengths and the different diameters of the water main. So the majority of it was 280 mil OD. They're the main trunk mains down either side of the road. So here's just some images sort of showcasing the difficulties. So the top left there is Fairview Park. You can see where we're digging out either side, trying to maintain existing services in place and tread a water main below. The bottom, the picture on the bottom left there shows different connections. Green ducts being the new DCC fibre. The twin wall just there sticking up out of the ground is a public lighting column foundation. So you can see that all the different sort of utilities fitting in together. The other images show the complexity of the different trenches trying to get the water main through. On the far right, the connection of the 5 lamps, you can see that this was all detailed. All of these blocks were detailed. The T-pieces were brought in, all of the bends. It was a huge undertaking. We're very proud that we got there. So I'll also then talk about the tree pits, and I can't take all of the credit here. We have our partners, our landscape architects from CSR with us today, who put a huge amount of effort into these and a lot of consultation with DCC Parks. So we started looking at tree pits. We had a talk about, was it the Stockholm system? Was it the crate system? The Stockholm system, you know, it gives nutrient-rich aggregate for the tree to grow in, and the crate system provides a sort of a void filled with nutrient-rich material. Ultimately, with a lot of consultation with DCC Parks and their experience, and then ultimately they will be the maintainer. Their preference was to go with the crate system. The crate system, it has its benefits. If it was the Stockholm system, a third party might come along and just think it's normal soil, dig through it, ruin the root ball, ruin the roots, kill the trees. So, but if a third party contractor does come here down the line, they'll see the crates and hopefully leave them alone, allowing the tree to grow naturally and healthily. So when it was coming to the construction or the design, you know, the shape is not necessarily the most important factor, especially when you're in an urban environment. You're not going to get that perfect square and depth every time. It was the volume. Once you get the volume for the tree to grow into, so that it has enough soil to establish itself, and then as it propagates into the ground around it should thrive. And existing utilities was a big issue as well. So we did a huge amount of work on it. Some services we left going through the tree pit because it was acceptable. Others we diverted. Anything was proposed, we diverted. You can see the image there on the right. That's actually 2 tree pits that are linearly connected together. So that's a much bigger area for the tree to go into and hopefully thrive and be there for another 100 years, like some of the trees that are there already. Just some images of the complexity during construction. You see some of the existing utilities are wrapped in root barrier to make sure no roots get in. So you can just about see pointer is working. Just about see the crate system here that's been slotted underneath the existing utilities, and this is infrastructure allow air and water into the root balls. I just a special note on these. Anybody who's gone through detailed design, these are ESB, very immovable, cause a lot of problems on site. Get water into them, they break, cover over, and then the ESB come back 6 months later and dig up everything we've just done. So it should be noted that they should be dealt with a special care or diverted at best. Just some more images for the trees as they come up out of the ground. So you can still see the crate system just here, and then a bit of a surrounding, and the tree will go in here. So give it the best, and then some of the finished product there on the right. I think it was very successful. I think we got through it on site pretty well, and I think everybody's happy with the trees going in. It brings a lot to the streetscape, I think, especially for a commuter route where it's previously a very sea of grey and buildings and tarmac and cars. It does change the appearance of a road greatly. Another part of the SuDS elements that we tried to implement was bioretention areas. So the design intent for this was to manage the carriageway runoff locally in small sub-catchments. So a lot of the route was served by the combined sewer, as I said. So every time it rained, water into the gullies, combined sewer, and then went down to Rings End. So you know, it's putting Rings End under huge pressure that carriageway runoff is being brought down there to be processed in the Rings End facility. So we have 2 types of bioretention areas. One was impermeable and one was permeable infiltration. We went across the whole site. We looked at various different locations along the site where we could do it. So pull-ins for parking bays, anywhere that we had sufficient footpath space, was there space behind us. We initially identified 92 different locations, and then we went on to assess them The three main criteria we used in the assessment was geometry. Could we alter the local levels to allow the water in? What sort of utility congestion was there? Is it buildable? And then suitability. So, you know, some of the sites were just too small. We said it's not really worth providing a full bioretention or infiltration area. But they were used as just over the edge grass, greens, landscaped areas. I think we initially ended up with about 10 going to construction. Some were pared back. We ended up with 6 after construction. And the only thing that we couldn't build, we changed into a landscape over the edge, so it was still taking some of the runoff. And that's in addition to a lot of the other sort of grass areas we have. So the two sort of types of bioretention area we had was edge of carriageway and edge of cycle track. So the operation is the water comes off through the gap onto a spillway to slow it down, so it doesn't erode the soil in it, and then into the landscaped area. So the construction detail, and it might look a bit OCP, but when we looked at it, especially the edge of road ones, so the soil within the bioretention area is a high void, non-compacted soil. So when it's right beside the road, we were concerned that over time the road would just slip into the bioretention area and be a huge maintenance problem for DCC going forward. So at the road edge, we have retaining walls, just to keep the carriageway up and take care of the wheel loading. So on the left area of the permeable bioretention area, so the function of it is water goes in, permeates down, some of it evaporates. We put in a sort of a fail safe that if in any scenario the water builds up in the system, we had an overflow gully that went back out into the drainage system. And then the impermeable one was just lined with a liner. So the difference was when the city centre there was a lot of basements, so we were concerned that additional groundwater into the location of these basements might add water into these basements and ultimately undermine the foundations or just flood them. So around a lot of this area down Buckingham Street where we have these, they are just bioretention areas. So just a couple of images. So the one top left is the rebar fixing prior to concrete pouring. The next stage then is the concrete pouring on the right. So you can see the scale of the demand in the back. So they are quite large. There's a sizable amount of water that can be held in them even after the soil is included. And then the image there on the bottom left is the finished product, which, as I said, it adds a lot to the streetscape. Never mind also providing a function of reducing runoff. Just some more images. So just at the top of Altyburn Road, we included a swale. That was one of the first ones to be built. So that the top left there. So that has had a good growing season. So you can see that it's starting to mature. It's quite nice. And then there's just a few more different images. So Owen has put me under pressure here to crack on. So pavement design. So as Joe said, there was a huge amount of full road pavements along the whole scheme. We went through some different steps. So visual inspection, FWDs, GPR surveys, pavement cores. So they all sort of determined where there was visible deterioration, rebuild, where the pavement core said or the FWD or the GPR or the pavement cores indicated that there was insufficient depth in pavements, or the subgrade was degraded and that was replaced. We also looked at where existing trenches and proposed trenches, like so a lot of places, there was just so many trenches that there was very little existing road left. So that all went as full reconstruction as well. And then also design levels. The image there at the top right is a heat map from the Pribble level. So that's different. Each colour is a different distance, either above or below the existing ground level. So we sort of looked at each location, if it was 50 mil, 100 mil below ground level or above, and that sort of determined also where we needed full depth reconstruction. So just some quick images. So we had, just to run through, so we full depth reconstruction. We had plain and inlay of 100 mil. We had plain and resurface that was just the wearing course. And then one or two other sort of different tie-in areas. So each of these had a glass tex layer. The full reconstruction had a geomembrane at the bottom as well. The glass tex works very well. We put it on S2S many years ago, which was a concrete road underneath the wearing. And 10 years later, there's still no reflective cracking or anything like that. So if you are doing pavement works within the city centre, it will give you a lot putting in the glass tex. So the challenges during construction. we had to get a lot of additional pavement cores. When we got there on site doing slit trenching, we found in a lot of the closer to the city centre there was road on top of road on top of road, which wasn't ideal. And then also traffic management, and which was as Joe alluded to already. It was very challenging to do a full road reconstruction in the city centre with that level of traffic, and I think DCC traffic pushed their limits to make sure that we got there. And also we developed an on-site tool for site staff to determine build-ups at short notice. So on contract documents, was a very, very comprehensive contract document. It was a PW CF3, nearly 700 pages in the specification. We had a pack of 708 drawings. There was 308 pages in the pricing document. I think there was 20 odd pages of alterations to the TII method of measurements. And just I thought it'd be interesting for people just to have a look at the split of the costs in the BOQ. So obviously it's urban, with a bit of urban realm, a lot of granite, so the curbs, footways, paved areas is one of the top percentages. Next would be the pavements, utilities, earthworks. The earthworks also includes demolition of any old chambers. Preliminaries, water mains, 7%, landscaping, which was huge. Site clearance is an interesting one. I think we had 3,500 items of existing infrastructure that was above ground and into the catalogues. Each one had something different to be done. Some was kept, some was bin, some was back to store. And lighting at 2% and the traffic signs and road markings. Okay, so this is a repeat of what Joe's slipped in here. So there was a huge amount of people that we had to consult with over the 7 years that we've been involved in this project. And it brings a huge amount when you engage with these people. Like they are the departments that know their assets. They know they are the maintainers. So it's always good to consult with them and collaboratively get a scheme that works best. So I think I'll pass on to my colleague Colin. Thank you.
Thanks, Thomas. So I'll take you through some of the finer details. For example, curbs, as you see here. So for the grade separated and fully segregated cycle track to work, it was necessary to design all the curb types from scratch. There were different curb types used for various scenarios, such as at side roads, cycle tracks, and at bus stops. In all, there were 28 different transition curbstone types were used to tie the different curb profiles together. So you see them there in the bottom right, the various different transition stones. So they were end of curb pieces or drainage channels, slot cuts, that kind of thing. Curbs were tagged and color coded to help identify them on the drawings. And isometric drawings were created using SketchUp to make understanding the various scenarios simpler for the contractor. So the SketchUp model on the top right there it shows how we color coded all the curbs, and it made it a lot easier to identify how to construct things on site. We also use curb gullies on the bus lane to help improve the ride quality for the bus lane. So on the scheme, there was several interesting structures, and probably the most notable of all was the Conley Station Wall on Amiens Street. So to create enough space to facilitate the inbound footpath and cycle track, it was necessary to acquire a strip of land from CIE at the Amiens Street offices. A section of the CIE retaining wall and railing were then realigned. To ensure that this was done with the utmost sensitivity, a 3D Revit model was completed to facilitate accurate drawings to be developed. The railing was carefully dismantled and repaired off-site by Bushy Park railings. The reinstated wall and railing have retained the character of the area, and all works were completed under supervision of our conservation architect on site. The image on the bottom right there is the railing as it stands at the minute, and I think it looks great, to be honest. Probably looks better than it ever has or has done in the last 60 years. Nice lick of paint. Another structure was the James Larkin House wall on North Strand Road. So to create enough space to facilitate the inbound and outbound cycle tracks, it was necessary to acquire a strip of land at the James Larkin House residential complex to construct a new retaining wall. During excavation for the wall, the remains of some houses which were damaged during the World War II North Strand Road bombings were uncovered, and an extensive landscape and planting plan was implemented when the wall was complete. So that image on the bottom right there is as it a finished product with our trees going in, and a lot of work from CSR going into that too. And our exposed aggregate concrete path there, I think it looks pretty good. The North Strand road wall. So as part of the scheme, this was realigned to make room for the inbound footpath and cycle track. The wall was carefully rebuilt using the original stone to retain the character. The reinstatement of this wall was actually so important to Dubliners that it became a topic of discussion on Liveline. And we're obviously glad to report that Joe is happy with the finished wall. There's been no complaints since. Signal installation. So an interesting aspect to the scheme is the use of cantilever traffic signals at the junctions. Cantilever traffic signals were introduced at the junctions as most of the central islands were removed throughout the scheme. Installation of the large cantilever sockets was a challenge given the number of existing utilities in the ground. The image below there shows one of our cantilever sockets, the 250s, and the number of utilities in around it, and each, not each, but a lot of the foundations had to be bespoke designs. Consideration had to be given to abnormal size loads coming from Dublin Port, which couldn't use the Dublin Port tunnel. We'll discuss that now. So it was a design requirement to maintain access between the Offyburn Road and the Malahide Road for oversized vehicles coming to and from Dublin Port. A comprehensive assessment was carried out on the proposed layout to ensure that there would be no clashes between these vehicles and the proposed street furniture. So the image on the top right there is one of these oversized vehicles as it passes beneath the Northern Line rail bridge, and it just gives you a sense of the scale of these vehicles that we had to accommodate. We were also required to install 2 swinging cantilever signal poles on the Offyburn Road. And during the works, the N2 and N4 orbital routes were proposed, which required a slight adjustment to the Holt Road junction layout to allow our buses to make their way through. So the image there on the bottom right are the tweaks that we had to make to the central islands and stuff on the Holt Road for these new electric buses that the NTA have purchased. And I think that's back to all.
We were aiming to be done by 7:15, and we have abjectly failed at that. So sorry about that. But like, I mean, you could have spent half an hour talking about an awful lot of those slides like that, and hopefully Clonmel will add some of the detail in a future presentation, but even how the railing at Connolly Station had to connect to a particular type of stone and not the other type of stone, and the issues we had there. I mean, it was really huge. So look, I'm going to fly through this. The tender process, we went from 9 to 6 to 3. Fair play to DCC, and the NTA. They agreed. We were trying to impress that the importance of getting the quality right on this job was so high, to get the traffic management plan right, to get the communications right, to get the program right, to get the resourcing right. So this is probably the first job like this in the country which was awarded more so on quality than on the price aspect. Anyway, Clonmel ended up emerging out of that December 21 and started work in March. So there's the official launch, a number of the local councillors and Oliver from the NTA, and that was the Lord Mayor at the time. So then the construction was originally envisaged 600 days, which, I mean, we all knew was unlikely to be achieved. But if we had said 800 days, it would have taken 1,000. So the hope was if we said 600, it would take 800. It's more or less done now. There's a last bit. I mean, Thomas mentioned the electricity cables. Like, the ESB have done their best to help us through the job, but the ESB are being pulled every which way. These old dilapidated cables are a disaster. They just keep blowing. I think on other smaller jobs around the city, since DCC has got the ESB to go in there first and fix their cables before they ever start, I would highly recommend that for anything like this again, because when an ESB cable blows, everything has to be stopped. We obviously then, because we overran the 600 days, we got into another summer, and there was like, I don't know how many concerts in Croke Park that summer. And then someone thought it was a great idea, for the first time ever, when we were starting such a big roadworks job, to do concerts in Fairview Park as well. So we had 2 weeks of that every year. Principal construction challenges. So, I mean, we've been through a lot of it. I mentioned the site compounds, really big issue. Getting all the DCC apartments aligned in time to keep the contractor moving. Joe's team has worked tirelessly on that. Then changes, like you always have changes. The bus stop crossings have been a nightmare. Oversized vehicles, we had to make tweaks for those. Add bus stops back in, which I won't say any more about. Additional accommodation works and heritage lighting columns. Like, they look innocent enough, these lighting columns, but they're extremely expensive, extremely fragile, and turned out no one actually knew what was in them when we went to take the first one down, but we got through it. And of course, inflation. I think someone mentioned, I don't know, is this absolutely true, but it's definitely around the same time. But the day we started on site was the day the war started in Eastern Europe, and we immediately had 10% inflation. Lessons learned. This consultative forum, I've said it already, Joe has said it, has been fantastic. And the engagement from the councillors and the public and the guards and the Dublin Cycling Campaign, Cyclist.ie now, has been fantastic. Probably like all the drainage. Yeah, we walked it in the rain the other day. Nothing is ever perfect, but we could definitely have put one or two more gullies in the cycle track. Like, but every gully put in looks like the small little thing above ground and is about that size below ground. So you have to move all the water mains and the sewers to get it in, but it would have been worth doing one or two areas. We had problems with one or two old buildings, one in particular. But look, we had great cooperation, and we just have to accept that you can't keep everyone happy all of the time. So in terms of thanks to the consultative forum, to the DCC team at all levels, Brendan and Andy were the directors and Chris was the deputy director. We've had 4 DCC project managers on the job over the course of the project, and I'm delighted to see Fiona here tonight. Victor is off sunning himself. The DCC project engineers, poor Joe has had to deal with the worst of this over the last 2 years on site, but Pádraig did his time before that, and before him, Tony McGee as well. And we had, you know, the rest of the site team, John, Mohammed, Tony, Kieran and Michelle, the planners. Like, we can't do justice to all the DCC department who were involved in this, all the people that helped us. There are too many people to thank. So I won't risk naming any because I'll just offend those I leave out. But it did involve huge cooperation from all the departments. The funding agency, of course, Ian Rodarin and CIE, really helpful to us. Ishka Aaron, Stephen Burke, who was the senior engineer in DCC Water at the time of the design, moved over to Ishka Aaron. I mean, it was brilliant. They took the opportunity while we were building this job to do all the water mains, and they paid for them. I mean, that's great interagency cooperation. We've mentioned CSR, ACOM, Kevin Cleary did the public lighting, and Peter Monaghan, of course, was the road safety auditor who gave us a, what was it, 70-page safety audit for the stage 2. But as ever, Peter was extremely helpful to us getting through it. And last but certainly not least, Clonmel. When Trevor heard we were giving a talk on how good the design was tonight, he went to the lash, so he's not here to join us in despair. But Clonmel have been super, you know, and they've been brilliant dealing with the local community. So just a few before and after pictures to finish up. That's what it was. That's what it is now. I mean, look, I think the way we've managed to stitch the old materials and the new together, I'm quite pleased with how it's turned out. And again, we managed to keep a lot of these old trees and fit our new infrastructure around it. So you'll be very relieved to hear that's it.